Let's solve practice set 3.5. Question first. In figure, ray PQ touches the circle at point Q. PQ equals 12, PR equals 8, find PS and RS. Okay. Question first, solution. First of all, let's redraw the diagram and let's try to mention given information in the diagram. Okay. Here in figure, line PQ touches a circle at point Q and line PRS intersect a circle in points R and S such that PQ equals 12, PR equals 8, find PS and RS. Okay. We learned theorem of tangent second segment or tangent second segment theorem. According to that theorem, PR into PS equals PQ square, and on substituting known values we can find answers of questions which are asked in this question. Okay, let's mention in a solution. From figure tangent PQ and second PRS intersect each other in exterior of circle at point P, and therefore PR into PS equals PQ square dash dash by tangent second segments theorem. Okay. Therefore, let's put known values. PR we know which is 8 into PS. We don't know value of PS. Is equals PQ which is 12. Here PQ square means 12 square, and therefore 8 into PS equals square of 12 is 144. Therefore PS equals 144. Multiplied 8 of PS will become divisor of 144. 144 divided by 8. 8 ones are 8, 8 ones are 8. Remainder would be 6, and on putting 4 on that 6 we get 64. 8 8s are 64. Therefore PS equals 18. Let's call it as equation 1. Now PR plus RS equals PS. PR plus RS equals PS. Since P dash R dash S, therefore PR which is 8 plus RS we don't know. PS just we calculated which is 18. Therefore RS equals 18 minus 8 and therefore RS equals 10. Equation second. And therefore PS equals 18 and RS equals 10. Question second. In figure, chord MN and chord RS intersect at point D. Sub-question first. If RD equals 15, DS equals 4, MD equals 8, find DN. Sub-question second. If RS equals 18, MD equals 9, DN equals 8, find DS. Okay. Now, let's solve these sub-questions one by one. Question second. Sub-question first. Solution. Okay. In figure, chords MN and RS intersect each other in point D such that given information is RD equals 15. Okay. RD equals 15. DS equals 4. DS equals 4. MD equals 8. MD equals 8. Okay. Find DN. Yes, you may note chord MN and chord RS intersect each other in interior of a circle at point D. Okay, we may apply in this case theorem of internal division of chords. According to theorem of internal division of chords, MD into DN equals RD into DS. Okay, let's mention. From figure, chords MN and RS intersect each other at point D in interior of circle, and therefore MD into DN equals RD into DS by theorem of internal division of chords. Okay, and therefore now let's put known values. Okay, MD which is 8, MD means DM which is 8, DN means ND which we don't know, RD that is DR which is 15, DS means SD which is 4. Okay, and therefore DN equals 15 4s are 60 and multiplied 8 of DN will become divisor of 60 at right side. 8 1s are 8, 8 7s are 56, remainder will be 4. There is no digit to take, that's why putting decimal and by taking 0 and 4 we get 40. 8 5s are 40 and therefore DN equals 7.5. Okay, now let's solve second sub question. Sub question second of second solution. Let's see given information of second sub question. If chord Mn and Rs intersect each other in interior of a circle at point D. Okay, chord Mn and Rs intersect each other at point D, such that if Rs equals 18, Rs equals 18, okay, Rs equals 18, MD equals 9, MD equals 9, Dn equals 8, okay, Dn equals 8. Find ds. ds equals what much? Okay, again you may note chord Mn and chord Rs intersect each other in point D in interior of a circle, and therefore by theorem of internal division of chords, MD into Dn equals Rd into ds. Okay, we are interested to find length of ds. Let's give it solution. From figure, let ds equals x. Let ds equals x. And therefore, as Rd plus ds equals Rs, since R dash D dash S, and therefore Rd plus x equals 18, and therefore Rd equals 18 minus x. Let's call it as equation 1. Now chords Mn and Rs intersect each other in point D in interior of circle. Therefore, MD into Dn equals Rd into ds by theorem of internal division of chords. Therefore, let's put known values. MD which is 9 into Dn which is 8 equals Rd 18 minus x and ds x, and therefore 9 8s are 72 equals x into 18 gives us 18x, x into minus x gives us minus x square, and therefore on transfer of right terms towards left side we get x square minus 18x plus 72 equal to 0. It is quadratic equation in a form of x square plus bx plus c equal to 0. Let's factorize the product of a into c such that its addition would be b. Means 1 into 72 gives us 72, and 72 should be split such that their addition would minus 18. Yes, 12 6 are 72, and sign must be minus, because minus into minus gives us plus in a case of product, and minus 12 plus minus 6 gives us minus 18, and therefore it will be x square minus 12x minus 6x plus 72 equal to 0. Group of first two, group of next two, and therefore x in a bracket x minus 12 minus 6 in a bracket x minus 12 equal to 0, and therefore x minus 6 into x minus 12 equal to 0, and therefore x minus 6 equal to 0 or x minus 12 equal to 0, and therefore x equal to 6 or x equal to 12. That is, yes, we are interested to find length of ds, which we considered as x, that is ds equals 6 or ds equals 12. Hence the solution. Question third. In figure, O is the center of the circle and B is a point of contact. Seg OE perpendicular seg AD, AB equals 12, AC equals 8. Find AD, DC, DE. Question third. Solution. Let's redraw the diagram and let's try to mention given information in the diagram. It tells us that B is a point of contact. Okay. And you may note line ACD is a second. O is the center of a circle. OE is a perpendicular through center of a circle on a chord, and we know that perpendicular drawn through the center of a circle on a chord bisect the chord, means DE equals EC will be there. Line AB is a tangent. OE perpendicular seg AD, AB equals 12. Okay, AB equals 12. And AC equals 8, and he is interested with find AD. AD equals what much? DC equals what much? Okay, DC, and DE equals what much? Let's give it solution from figure. AC into AD, AC into AD equals AB square by tangent secant segment theorem. Okay, and therefore let's put known values. AC, which is 8, into AD, we don't know. Let's keep AD as it is, equal to AB square, but value of AB is 12, that's why it will 12 square, and therefore AD equals square of 12 will be 144 upon multiplier of AD, which is 8 in a previous step. Now that 8 will be the divisor of 144. Okay, AD equals 144 divided by 8. Then 8 ones are 8, 8 ones are 8. Remainder would 6, and on putting 4 on 6 we get 64. 8 8 is 64, and therefore AD equals 18. Let's call it as equation 1. Now AD is made up of AC and CD. Now AC plus CD equals AD, since A dash C dash D, and therefore AC, which is 8, plus CD, we don't know what is the length of CD, that equals AD, which is 18, and therefore CD equals 18 minus 8. Therefore CD equals 10. Equation 2nd. Now OE perpendicular CD. Since OE is perpendicular to AD, OE is the center of a circle, OE perpendicular to CD, and CD is the chord of a circle, and we know that perpendicular drawn through the center of a circle on a chord bisect the chord, and therefore we can write there, therefore DE equals CE equals half of CD, since perpendicular drawn through center of circle on chord bisects the chord, and therefore DE equals EC equals half of 10. 2 1s are 2, 2 5s are 10, and therefore DE equals EC equals 5, and therefore DE equals 5. Equation 3rd, and EC is also equal to 5. Equation 4th. Question 4. In figure, if PQ equals 6, QR equals 10, PS equals 8, find TS. Okay. Question 4th. Solution. Let me redraw that diagram and let me mention given information in that diagram. Okay, here you may note. Here are chords intersecting each other in exterior of a circle. Chord TS and chord RQ intersect each other in exterior of a circle at point P, and we know theorem of exterior division of chords. By theorem of exterior division of chords, TP into PS equals RP into PQ. Okay, and putting values which are given, we can find value of TS. Okay, PQ equals 6, QR equals 10. Okay, QR equals 10. PS equals 8, and find TS. We are interested to find TS. Okay. From figure RP equals RQ plus QP. Since R dash Q dash P, and therefore Rp equals 10 plus 6 equals 16. Number 1. Now chord TS and chord RQ intersect each other in point P in exterior of circle. Therefore TP into PS equals RP into PQ by theorem of external division of chords. Okay, and therefore length of TP we don't know. Let's write TP as it is into PS, which is 8, that equals RP, just we calculated, which is 16, into PQ, which is 6, and therefore TP into 8 equals 16 6 are 96, and therefore TP equals 96 upon 8. 8 ones are 8, 8 ones are 8, remainder is 1. By taking 6 we get 16, 8 twos are 16, and therefore TP equals 12. Equation first. Now TS plus ESP, TS plus ESP equals TP, since T dash S dash P, and therefore TS plus value of SP is 8 equals length of TP is 12, and therefore TS equals 12 minus 8, and therefore TS equals 4. Equation second. Question 5th. In figure, seg EF is a diameter and seg DF is a tangent segment. The radius of the circle is small r. Prove that DE into GE equals 4r square. To prove DE into GE equals 4r square. R is the radius of the circle. Okay. Now let's mention proof. From figure, line DF is a tangent and line DGE is a secant. Okay. From figure, line DF is a tangent and line DGE is a secant. Okay, and therefore DF square equals df square equals dg into de. dg into de. Equation first. By tangent second segment theorem. Okay. Now in a triangle DFE, angle DFE equals 90 degree, because DFE is a tangent, EF is a diameter, means HE is a radius, and we know that radius through the point of contact of a tangent is perpendicular to the tangent. Angle DFE equals 90 degree by tangent theorem. Okay, and therefore DE square equals DF square plus EF square by Pythagoras theorem. Okay, and therefore DE square equals DF square plus EF. EF is a diameter of a circle, and diameter of a circle is twice of radius. That's why EF will be 2r. Let's put here EF as 2r its square. Since EF equals 2r means diameter is twice of radius, and therefore DE square equals DF square plus 4r square. Okay, and therefore 4r square equals DE square minus DF square. Okay, and already we have DF square equals DG into DE. Therefore 4r square equals DE square minus DF square is nothing but DG into DE. Okay, DG into DE from 1. DE square means DE into DE equals DE into DE minus DG into DE. We will take out DE common, therefore it will DE into, in bracket, DE minus DG. Okay, now DE minus DG gives us GE, since D dash G dash E. Let's write here that equals DE into GE. DE into GE. Since D dash G dash E, and therefore 4r square equals DE into GE, that is DE into GE equals 4r square. Hence the proof. Thank you.